You can see the screen.
Yeah.
So how many? This is what one complete unit or what?
Yeah.
How much time they take to cover this unit?
2 weeks.
Okay.
But this one's easier than the last unit.
Okay. So what is the current unit?
Unit 2 forces.
No, what they're discussing in the class.
FBDs, elevators, springs.
So second unit or something else?
Second unit.
No, no. What are they discussing now, right now in the class? Is it unit 2 or unit 3?
Unit 2.
Okay. So you have tried all these questions or?
I answered them on my iPad.
Have you got the answers correctly?
Well, I do need help with some of them.
No, answer key they are given, right?
Yeah.
So how many have you got? How many? Where is the answer key?
It's on a separate document.
Okay. But the first part they are given the answers here itself.
Yeah.
Okay. You have any questions that is difficult? You want to discuss it?
Yeah. The first one.
This one.
No. After that page. Like use the following. Yeah, that one.
So we have velocity versus time, right?
Yes.
Uh, so so whenever you have a graph, velocity and time. So what does the slope of this graph indicate?
The acceleration.
Okay. What about area under the graph?
Displacement.
Yeah. So that is the first thing you have to see. Okay. And then he's asking which section of the graph corresponds to largest force. Okay. So how is force information in this graph?
A constant velocity.
No, no. Slope of the graph is acceleration, right? How is acceleration?
Oh,
Huh?
F net equals ma.
Okay.
So A equals F net divided by mass.
Okay. What is F net, right? Just keep it like that. F net equal to m into a, and acceleration we have from here, right?
Yeah.
As a slope. So slope is acceleration. So from that you know the acceleration. So if you multiply acceleration by mass, we'll get the force.
Okay, so it's 2 kilograms. That's the mass of the object.
Yeah.
Okay, so it's 2 times the acceleration is I'm not sure what the acceleration is.
No, we have to find which has got the maximum acceleration. Largest force means largest acceleration, right?
Yeah.
Okay, so which part of the graph has got maximum slope?
3 seconds.
Okay, there is no second, it's the third part.
Oh, okay. At 3, yeah.
Actually, the slope here, which section corresponds to application of largest constant net force. Another thing he's saying is constant.
So it's not changing.
Yeah. So constant net force means what? Acceleration is constant.
Yeah.
because F equal to M into A. So F is constant, M is constant.
Mm-hmm.
So F is constant when acceleration is constant. So in this graph, acceleration is constant which interval?
5
What?
at 5 seconds.
Don't say 5 seconds. It's a fifth interval.
It says time at the bottom.
No, it's a time interval. It's not seconds.
Oh, okay. So at the 5th interval.
Fifth interval, the slope is changing, right?
Oh, I meant to say 4th.
What about third?
It's increasing,
Value is increasing. What about slope?
changing.
Slope of a straight line is same, right? At any point.
Mm-hmm.
So the slope is same. There's the property of a straight line.
Okay.
Property of a straight line is between any 2 points. The slope is same. Here the slope is 0.
Okay.
So any other interval where the force is constant.
No.
What about 2?
Isn't it 0?
It is 0. Zeros are constant, right?
Yeah.
So it is constant in 3 intervals. So what are the 3 intervals?
2, 3, and 5.
Yeah. So those 3 intervals, it's a straight line. Okay. Slope of a
Mm-hmm.
straight line is constant. So force is constant. Acceleration is constant. So force is constant. And acceleration is 0 here, and here has got some value.
Okay.
And so, and this is a positive value. Slope is positive here.
Okay.
Because slope is positive means when x is increasing, y is increasing. Or the angle is making a positive slope with the x-axis. So this is a positive constant. Here it is 0, here it is 0. So this is the part where the force is acceleration is maximum. So force is maximum. So the answer for second one is interval 3. Check the key.
Okay. Yeah, it's right.
What is the reason?
Acceleration is proportional to F net. So the steepest slope means longest F net, and the constant acceleration means constant F net. So the steepest straight segment is the answer.
Yeah, because see here actually here the slope is more. This part the slope is infinity. Okay, but it's not constant. It's changing, right?
Mm-hmm.
Here also the slope is infinity. Infinity means vertical line. Vertical line has got slope infinity. That you know, right?
Mm-hmm.
Horizontal line has slope is 0. Slope means not. You should be able to climb up.
Okay.
So in the horizontal line, you are not able to climb up. Okay, so that's why the slope is 0. In the vertical line, you can climb the maximum fastest. So here at this point, the tangent is vertical line at this point. So here also the
Okay.
tangent is vertical line. So the slope is maximum here, but the slope is not constant. So that is why these two things don't come in this particular question. In this particular question, they are saying constant net force. So only straight line parts will come.
Okay.
Okay. So among these 3 straight line parts, this part is the one which has got maximum slope.
Okay.
Right. In next thing is in which section the graph is net force is changing.
1 and 5.
Yeah, 1 and 5. Third, it's not changing, but it's constant. See,
Yeah.
force will change whenever acceleration is changing. Acceleration will change. Acceleration is same as slope. So in the third part, the slope is constant throughout, so it's not changing. So only in 1 and 5, the slope is changing. So acceleration is changing, so net force is changing. So it is 1 and 5.
Okay.
Then, which one you want to discuss?
I'm scrolling. Okay, so where is it? Number 27, but it's a picture. It's right before it. Yeah, that's it.
Okay, so what are the forces acting?
FN and FT and FG.
What is FT?
Force of tension.
Okay,
'Cause-
FG.
Yeah.
Only two forces. What about FN?
Isn't there no FN?
Why? Then how will you feel the flow? If normal reaction is 0, then you will not feel the flow. But in the left, you do feel the flow, right?
Okay.
While sitting on the chair, you feel the chair, right?
Mm-hmm.
So that means there is a normal reaction between you and the chair. Similarly, while standing on the floor, you do feel the floor, right?
Yeah.
So that is because the normal reaction between you and the floor. So similarly, standing in the lift or when the lift is moving up and down, you still feel the floor.
Okay.
So there is normal reaction. So the normal reaction will be upwards, FG will be downwards, FT will be upwards. So three forces are there and it is accelerating downwards. Okay. So,
yeah, I get that.
But is the acceleration uniform? Is it same throughout?
No.
So how does it change?
It slows down.
No. First it is starting with rest, no?
Mm-hmm.
So how will it slow down then? If it slows down first when it started, it will not move at all. Initially it is not, it is zero. It's zero velocity. Zero
Okay.
speed, right? So starting itself is slow down, it will not move at all. So initially it will start to pick up, right? After that,
Um. it'll start to speed up.
Okay. After that,
It'll slow down again.
okay. So this is similar to the case when when you start a vehicle and move to if you're moving from one place to another place in a vehicle, say a
Mm-hmm.
car. Okay. How will the motion of car be? Initially, it will start from rest, right?
Yeah.
And then speed will increase or decrease.
Increase.
Okay. And then,
It'll slow down again.
yeah, but what happens between increasing and slowing down in between?
What do you mean?
No, when you're starting, you increase the speed, right?
Yeah.
You'll keep on increasing the speed, or you'll say 0 to 100. You're increasing. After that, you'll still increase to 200.
No.
Now, then what will you do?
Slow down.
You don't have to slow down. You increase the speed to a particular comfortable value, and after
Oh,
that, you
you
make
just
it easy.
maintain it.
And then when you're stopping it, you reduce the speed.
Yeah.
So it will be like a trapezium. You know what's a trapezium, right?
No.
Four-sided figure.
Oh, a trapezoid.
Trapezoid is three-dimensional object. Trapezium is two-dimensional object.
Okay.
Okay, so it will be like going like this, and then maintaining the constant this thing, and then slowing down. Slowing down will be usually steeper.
Okay.
This is a general trend. Okay,
Okay.
because while increasing the speed, what you have to do is you have to inject more fuel into the engine.
Mm-hmm.
Okay, by slowing down, what you have to do?
Apply brakes.
Apply brakes means you just have to stop the fuel injection into the engine and then apply brakes. So this can be done quickly. This is just the rubbing of the tire with the road. That will bring this deceleration. This part is decelerating, right? This part is accelerating. Is it clear?
Yeah.
Uh,
Yeah,
y,
clear.
y-axis is velocity. X-axis is what?
Time.
Yeah. So this is positive acceleration. This is zero acceleration, constant speed, and this is negative acceleration, that is deceleration. Okay, so lift will also do something like this. From the beginning, it will increase its speed and then maintain its speed for some time. And after that, when it's stopping to the required floor, it will reduce the speed.
Okay.
So something similar should go on there. Okay, so can you check the key?
Yeah. Yeah, that's right.
Have they given velocity time graph?
Yeah, they gave both.
Both what?
Oh, they did not give a velocity versus time graph.
They are given this graph. What else they are given?
They didn't give anything else. They only gave the vertical motion map and then the FBDs.
So what is the motion map?
It was the one on the sheet.
No, you send me that PDF file.
Okay, one sec. think it's emailed to you now.
Okay, and free body diagram will have 3 forces.
No, in the answer key, there's only 2.
Which 2?
Fn and Fg.
Fn and Fg.
Mm-hmm.
What about tension? Okay, yeah, tension won't be there. No, see, tension is connected to the box of the lift, not to you. See, if you're drawing the free body
Okay.
diagram of the person, there's no rope connected to the person. Okay, the rope
Okay.
is connected to the box or the room, whatever it is, the container or the lift. It's not connected to the person. Okay, so
Okay.
that tension is indirectly providing the normal force. The tension is holding that lift, and the lift is giving a normal reaction to the person. So the effect of the tension is coming via the normal force. Got it?
Okay.
No? If tension is 0, normal force will be 0.
Okay.
Because if tension is 0 means it's freely falling. Tension is not there means nothing is holding it. No.
Yeah.
So nothing is holding means it will fall freely. When something is falling freely, you will not feel the floor of the lift, because if you have to feel the floor of the lift, you have to press it with some force, right? Okay.
Mm-hmm.
If you have to press it with some force, then the floor has to be stationary. But the floor is also falling with you, free falling. So when the floor is falling with you, you won't be able to apply force on the floor of the lift, and the floor will not be able to give a normal reaction to you. But when there is a rope connected to it, it's not falling freely. It will be falling at a speed lower than the speed corresponding to free fall. In that case,
Okay.
you will feel the floor. Okay,
Okay.
that is why tension of the rope is coming indirectly via the normal reaction.
Okay.
Have you seen it correctly? Huh. So what is the length of this arrow indicate?
Like how fast it's going.
Yeah, which quantity is it? Acceleration?
Oh yeah, acceleration.
How is so the length of the arrow is increased, no?
Mm-hmm.
So what does that mean?
Oh, you got cut off. Can you repeat that?
What?
I couldn't hear you.
The length of the arrow is increased, right?
Mm-hmm.
So what does it mean?
It's going faster.
Which is going faster?
The acceleration.
But acceleration is constant or it's different?
It's changing.
Oof. If you have this sort of a this thing, acceleration here is constant or changing.
Oh, constant.
Okay, but what is changing here? Velocity.
Velocity.
So velocity will increase. So this arrow is indicating the velocity.
Mm-hmm.
Okay, so the velocity is increasing from here to here. Vector, the length of the vector is indicative of the value. Arrow mark is the
Okay.
arrow mark is the direction. Vector has got two properties, no? One is the magnitude, other is the direction. So magnitude is indicated by the length of the vector, length of the arrow, and the direction is indicated by the arrow mark.
Okay.
Right. So this length of the arrow is increasing. That means the velocity is increasing. After that, it is remaining constant. This when you have two lines of same length, that you represent by dashing, right? You remember in maths, geometry,
Yeah.
if you have two lines of even angle, two angles are same, means you represent by in the same way. Same.
Yeah, you draw the marks.
So similarly, these two lines are of same length. That's why they have put the mark here. Okay.
Okay.
So this part corresponds to this horizontal part. Velocity is not changing.
Okay.
Okay. So that is a non-changing part, the horizontal part, and after that the velocity is decreasing. You can see why it is decreasing, right? The length of the arrow is decreasing.
Okay.
Right. And what does this double arrow indicate? Or the solid arrow here on the left?
That it's going down.
No, acceleration.
Or the acceleration's negative.
Acceleration downwards. Whether you call it negative or positive, that you can decide later. You don't have to say it's negative or positive. You just have to say up or down.
Okay.
Instead of saying negative, positive, then you have to say which direction is positive, which direction is negative. You don't have to say that. You just have to say up or down. That's what they said.
Okay.
Okay. So this accelerating downwards, and here is accelerating upwards.
Okay.
Okay. And here, what is the thing that you notice here? Fg, the value of Fg, the length of Fg vector, is it changing or same?
The same.
Why is it same?
Because they have the dash marks to indicate it.
Yeah. Dash mark is, but why is it? It is same because they have put the dash mark because it is same. But why is it same? Fg is a weight, right?
Oh, because in the very first instance, the elevator is not moving.
After that,
Well, when the elevator starts to go down, Fn is no longer the same as Fg.
no, but Fg is same, no?
Like throughout the course of the elevator
Yeah.
ride?
Yeah. Why is it same?
Because it's just your force of gravity. So it's your mass of the elevator times 9.8.
Mass of the person. It's this is free body diagram of the person.
Okay.
Because if you take the elevator, then the tension will come, the rope will come.
Oh.
Okay.
Okay.
Describe the motion of the elevator as you travel from. Okay, they have not mentioned it clearly, but it is the free body diagram of the person, because only the person inside will feel the normal reaction.
Okay.
Okay. If it is elevated, then the normal reaction won't be there, but tension force will be there instead. That's what I said in the some time back, right? The tension force is coming via normal force to the person. Okay, so if this is a free body diagram of the elevator, then instead of normal force, we'll have the tension. Okay.
Okay.
So only the person will feel the normal force. So Fg is constant throughout because it's because of the gravity, Earth's gravity, and Earth's gravity is not going to change. So always G, and Mg G is, so Fg is constant throughout. And in the beginning, when the thing is not moving, normal force and the Fg will be in balance. Okay. When it is going down, Fn will decrease. See, when it is acceleration is downwards, no? So you can write that equation. When the acceleration is downwards, it's Fg minus Fn equal to m into a.
Okay.
So Fn is less than Fg then. Got it? Acceleration is
Got
downwards,
it.
right? Acceleration is downwards. So the net downward force is Fg minus Fn.
Okay.
So Fg minus Fn equal to m into A, and that's a positive quantity.
Okay.
So Fg minus Fn is positive. That means that Fg is more.
Okay.
So Fn is less than this thing. But here they have put dash on both the things, right? So here, what is Fn and Fg? They are equal or not?
They are equal.
Why are they equal? Saying Fg minus Fn equal to m into A, right?
Mm-hmm.
So then why is it equal?
I mean, it has the dash marks.
Yeah, that is the result. That is the conclusion. But I'm asking why are they equal?
Because at that spot, the elevator isn't moving,
It is moving, right?
or it's moving at a constant acceleration.
See, Fg minus Fn equal to m into A, and the value of A is 0.
Okay, so the acceleration is 0.
Yeah. That
So
is
what
this
is
part,
that
right?
like?
This part, right? This part acceleration is 0.
Mm-hmm.
So Fg minus Fn equal to m into A, where A is 0.
So isn't the elevator not moving?
No. It's moving at constant speed.
Okay, but it's
One-
0.
Acceleration is 0. You can have moving with acceleration 0, velocity constant.
Oh, it's the force of gravity that's pulling it down.
See, this part, acceleration is 0, right?
Mm-hmm.
But it's moving because velocity is not 0.
Is it because the force of gravity is also pulling it down?
There are ye-
I know, but
what?
the normal force is the same as the force of gravity.
Yeah, net force is 0.
Okay.
But here the net force is not 0 here.
Yeah, because the acceleration is not 0.
Yeah.
But even in this instance, the net force is the same as the acceleration. So if the acceleration is 5 meters per second squared, your net force is 5.
Yeah, but this part, acceleration is 0. Yeah,
Okay.
that is this part. When you're
Okay.
riding a vehicle, you will not keep accelerating all the time. Then the speed will go to infinity. You will increase the speed initially. After that, once you reach a comfortable speed, you'll maintain that speed. When you're maintaining the speed, acceleration is 0.
Okay.
After that, you decelerate. Okay, so you don't have to accelerate all the time to keep it moving.
Okay.
Okay, so this part is acceleration is 0, so net force is 0, so that's why Fn and Fg are equal. And after that,
Okay.
you're decelerating. So decelerating, you can think as acceleration in the upward direction.
Okay.
Okay, so the upward force should be more, net force in the upward direction.
Okay.
So Fn is equal to Fn is more than Fg.
Okay.
And after that, when you're stopping, acceleration is 0. After stopping, not before stopping. This might be a little bit confusing. Here also, just after starting, Fn and Fg will be same because just after starting, acceleration is 0.
Okay.
So here, this part, actually no, this part itself will have acceleration non-zero, but before starting here and after stopping, just after stopping,
Okay.
got it? No,
Got it.
not while moving. So to be precise, it should be that is the understanding. This is after stopping. Okay, this is before starting.
Okay.
Okay, not after you uh, not after you enter the straight line part, just before that and just after that.
Okay.
That is a correct precise understanding of the thing. When it's accelerating, the downward force will be dominating gravity force. When you're stopping, the normal force will be more, upward force
Mm-hmm.
will be more.
Okay.
So this is the lift when it is coming down.
Mm-hmm.
So similarly, we can do for elevator going up. Elevator going up, you have to start from down. The
Okay.
figure, the figure is like the top part is like at a height, first floor. This bottom part is at a ground floor. I hope it is that is the case here. Uh, yeah, the arrow mark is indicating that, right? The direction of the arrow is the direction of velocity. Okay, so it is going up. So he's starting from. So this represents the ground floor, the last entry, and this represents the
Mm-hmm.
first floor or whatever floor, higher floor. Okay,
Okay.
so again the same thing. This dash and all they have left it because it's similar to this one only. Okay, you can figure out, right?
Yes. Wait,
Okay.
I have a question. This isn't about this though. So, like, if you have an object and you want it to move and you're gonna write an F-net equation, does it have to be equal to 0 newtons?
No, F net is m into a.
Okay.
That's always true. And when a is zero, F net is zero.
Okay.
So without F net, the object will not accelerate.
Okay.
Okay, but if it's already moving, if F net is zero, it will continue with that velocity.
Okay.
So the thing which is already moving, you don't need F net. That is Newton's first law, right?
Yeah.
That object will be at rest or at motion with constant speed if F net is zero.
Okay.
So when you want to accelerate, you need F net.
Okay.
Okay. So when you are starting, you need to accelerate, otherwise you will not move at all. Okay. But once you are in motion, you don't need F net because you can maintain that speed.
Okay.
So for maintaining the speed, you don't need F net. Maintaining the speed means acceleration is zero.
Okay.
Right. You don't should not look at the key. You first have to attempt the question. After that only you have to look at the key. The best thing is to attempt some 5 questions and then you look at the key. Otherwise, by looking at the key, you will look at the next question by accident.
Okay.
So I think you can figure it out on your own. Okay.
I
So
hope.
during what parts of the right is the normal force of the person? Yeah, I think these things I just told you.
Okay.
So the person will feel whether he's heavy or light depending on the normal reaction. Okay. When you are
Yeah. So
standing, when you're
when it's
standing in the,
going like down at the bottom, won't you feel heavier than you are at the top?
no, when the lift is going down, the
Mm-hmm.
normal force will be less.
Okay.
Okay, that's because when it's going down, the acceleration is downwards, right?
Yes.
So at least when you're starting to, sorry, when you're going down, the acceleration is downwards. So the normal reaction is Fn minus Fg equal to m into a.
So F net is what? Or normal force is what?
Normal force is just normal force. You just have to keep it as Fn. But Fg minus Fn is m into a when going down, and
Mm-hmm.
Fg is constant m into g. So Fn is less than Fg, right?
Yeah.
You feel the weight because of Fn, not Fg.
Okay.
Okay, because Fg is always there because of the Earth gravity. Okay, but what you feel as a weight is the normal reaction.
Mm-hmm.
Okay, so only because of normal reaction you will feel the weight. So if you're feeling lighter means normal reaction is less. So in this figure, where is hold on. See, the normal reaction here is more, right? Compared
Mm-hmm.
to here. So here you will feel more weight after it stops. This is after stopping. So before stopping, while going down, this normal reaction is more than the one at rest. So here you will feel more weight. Uh, Here in this case, normal reaction is more or less Fg minus Fn. Here Fg minus Fn equal to m into A. So Fg is more. So here the normal reaction is less. So here you will feel less weight. This part,
Okay.
because here acceleration is downwards. So Fg minus Fn is m into A, and m into A is positive. So that means that Fn is less. Here Fg equal to Fn.
Mm-hmm.
Here Fn is less than Fg. So here
Okay.
you will feel your weight is less. And when it is moving in the constant speed, again Fn will same as Fg, so you'll feel the same weight as when it is at rest.
Okay.
And here Fn is more. Okay, so here you will feel more weight. Okay, so when Fn equal to Fg, let's call it normal weight. Okay, so here will be more weight, and again there will be normal weight when it is moving at a constant speed. And here you will feel less weight when it is going down.
Okay.
When it is going down, means the floor which is touching your feet is going down, so you will feel less normal reaction.
Mm-hmm.
But when the floor is going down slower compared to your feet going down, then you feel more weight. At this point, the floor is going down, but your feet is going down faster than that. Okay, that's why normal action is more.
Okay.
Because the floor is the lifter is getting stopped. The floor is not moving faster, but you are falling freely, like falling in the gravity with the same speed, and the reduction of speed is
Okay.
happening because of this normal reaction.
Okay.
So just think about it. I think it will become clear.
Okay.
So in the lift which is freely falling, there the normal reaction is how much?
For which one?
No, if the lift is freely falling,
Yeah.
then what is the normal reaction?
Just going down.
Okay, so Fg minus Fn equal to m into A, right?
Mm-hmm.
And now freely falling means the acceleration of the lift is g.
Okay.
Okay, so Fg minus Fn equal to m into g. So what is Fn then? Just write it on a paper or whatever. Just write this thing. Fg minus Fn equal to m into A. Freely falling
Yeah.
means A is equal to g. So Fg minus Fn equal to m
Wait,
into
Fg
g.
minus Fn is equal to what?
M into A, right?
Yeah.
Freely falling means A is g. That is the
Okay.
meaning of that is the meaning of freely falling. Okay. So in that case, Fg minus Fn equal to m into g, right? Yes or
Yes.
no? Huh. So in that case, what is Fn?
Fg divided by ma.
No, Fg divided Fg minus mg, right?
Fg minus mg?
Yeah.
Isn't that the same thing? So isn't it just 0?
Yeah, Fn is 0, right?
Yeah.
Huh. That is the meaning of freely falling lift or free falling object. That's why in a freely falling lift, you will not feel the weight.
Because your normal force is 0?
Yeah, the normal force is 0 because the your feet is on the floor of the lift, but the lift is moving down.
Mm-hmm.
The lift is moving down, you're also moving down. So that's why you don't feel the floor of the lift. But if the lift is moving down slower than your feet moving down, then there will be sort of collision.
Okay.
Then you will feel the floor.
Okay.
So when you're standing on the floor of your house, the floor is not moving at all. Okay, but your feet will try to move because of gravity. Got it, no?
Yeah.
And that thing is stopped by the floor. That's why you feel the normal reaction.
Okay.
But in the lift, if the floor is moving down slower compared to the feet can move down, then you still feel the floor. Okay, but if the floor of the lift is moving down with same speed as the floor as that of your feet, then you will not feel the floor because you're just touching the floor. No, you're not feeling any force resistance due to the floor. Both your feet and the floor are just falling the same speed. Then you will not feel the floor because you can just touch the floor. That's a different feeling. But if you are resisting, you are moving down because of gravity, then you'll feel a normal reaction.
Okay.
Okay, but the floor of the lift is falling at the same speed as the person inside. That happens in the freely falling case. Okay, in that case, you will not feel the normal reaction. That's why when A is G, A is acceleration of the lift, when it is G, Fn is 0. I think you got it now.
Okay.
Okay, think
I
about
think I
it.
got it.
Yeah, so that is the meaning of freely falling lift. Okay,
Okay.
but here this lift cannot be freely falling because it will go at a very high speed. So that freely falling lift is stopped because of the rope attached to the lift. The rope is preventing the lift from falling freely. If it falls freely, it will fall at a very high speed. You'll go and crash at the bottom. Okay, you don't want that to happen. That is why the rope is there, and the rope is slowing it down.
Okay.
Okay, so if a person jumps from first floor to ground floor, and the lift is moving from first floor to ground floor, the person who is jumping will reach faster. Okay, that speed is very high, so you don't want the lift to
Okay.
go at that speed. So that's why the rope is there to slow it down. Okay,
Okay.
so the important catch is the weight is the normal reaction that you feel.
Okay.
All right. Okay. You want to try this one?
I finished that one.
First thing you have to draw the free body diagram. You have to follow the steps, otherwise you'll make mistakes in the test. Free body diagram is
Okay.
nothing. You just have to represent the student as a point or something. Okay, and then what are the forces acting on this student?
Fn and Fg.
Only two forces, right? Okay, and what about acceleration?
I mean, they're not asking F net equals MA.
It's an elevator, no?
Yeah.
Elevator will be moving.
So it would be, is he moving up or down? Okay. It would be Fg minus Fn equals MA.
If G minus Fn equal to,
MA.
yeah, so the question is whether it's moving up or down. See, since the scale reading is more, usually it is going up. When you're going up, you'll feel more weight.
Okay.
Okay. So Fn minus Fg is MNDA.
Okay.
So what are the normal force exerted on the student?
623 newtons
Why is it so?
because that's what the scale is reading.
Yeah. So basically, see, even in the weighing scale, if you use the weighing scale in the floor in the house, when you stand on it, there is a your weight is acting on the this thing, what on the scale,
Scale.
and the scale is exerting a normal force on your body. Okay. So in some sense, it's a normal reaction, which is suppose the scale is dropped from the first floor, okay, and you're also dropped along with it. Then what will be the reading in the scale?
Like in free fall,
Yeah,
0.
yeah, that's because normal reaction is zero.
Okay.
Okay, so the scale will read the normal reaction. Okay, and the
Okay.
normal reaction happens because of gravity and the relative motion between the scale and the person. If the both scale and the person are freely falling, even though gravity is there, there won't be any reading. It will be zero. That's because of motion between the scale and the the reading of the scale basically it senses the normal reaction.
Mm-hmm.
So it's not always M into G. Only it is M into G only when it is at rest.
Okay.
When it is at rest, the normal force is same as M into G. Okay. What about acceleration of the student?
I didn't calculate this.
How do you do that?
So it's F net equals M times A. So Fn minus Fg equals Ma. And then
Okay.
I would just substitute everything in.
Yeah, you'll get it. Fine. You want to try the next one?
Yeah, I did it. The first two parts. I got that one was easy.
You have to improve your handwriting. If
Okay.
not, you have to practice when you're at home only. If not, come studying the test.
It's just harder to write on the iPad.
Yeah, but while giving the test, you use pen and paper, right?
No,
Huh.
because I'm
Then?
at home. I have to do it on my iPad. And I can type.
Okay. But with practice, it will come.
Okay.
You're using a pen, right? I mean,
Um,
the digital pen.
yeah.
So that is same as the normal pen only.
No, I don't use that. I use my fingers.
Oh, I see. Okay. You can buy this thing,
A
drawing pad.
stylus?
Yeah. Stylus and a drawing pad. See, it looks like this. Can you see?
Yeah, I can see it.
And this is the stylus. So I just have to connect this into the laptop like a mouse,
Mm-hmm.
how we can connect a mouse. And then the stylus, and then you can write as a normal pen. This doesn't cost much.
Okay.
Actually, I think iPad also can be used like that. If you connect iPad to this
You don't
laptop,
need to connect it. You can just buy one on its own.
so you just have to buy this stylus then.
Yeah.
Yeah, you can ask your father. It should not cost much.
Okay.
Okay, any other question?
No.
I think you can try, or you can catch me tomorrow.
Okay.
You try. See, most important thing you have to take notes.
I am.
And
I
then
am
see
on my
another thing
iPad.
is you know what is shorter notes?
Yeah.
What is shorter notes?
I don't know.
See, first time when you're learning a subject, you have a lot of things that you don't understand. Okay, so that time when you are trying to take notes, the notes will be big, should be big. Okay, and when you're learning the same thing for the second time, most of some part of it will become natural or easy. Yes.
Yeah.
So the things which are obvious and easy, you don't have to write it down because it's there in your memory.
Okay.
Okay. So so the second time when you're writing, you write the things which are, it should be shorter than that.
Okay.
Getting the point, no? Because when you're revising, if you the time taken to revise, the shorter notes will be faster.
Okay.
Okay. So you should also take shorter notes. That way it will become clear to you also, because every time you look at the thing, then in the exam you will not have anything to look at, right?
No, we can use notes.
No, you can use notes, but if you look at when you're reading the problem, the solution should flash in the mind. Okay. Or the solution to come to the mind, how to go about it. That will happen only when things are pushed into memory.
Okay.
Okay. So the helping of thing pushing into memory will become, you'll encourage that if you use shorter notes, in the sense like you should try to solve without using notes. That may not be possible. That's why you have to use shorter notes. You have to encourage things to push go into the memory.
Okay.
Okay. So even though notes are allowed, that way even without you studying in the for the whole year, you take all the notes, just sit in the final test, and then you can write the thing. Right? That's not possible because even in the notes, how to connect different things, how to connect which part of the notes correspond to this question. So those things require understanding. So most of the notes should be there in the mind, in the memory.
Okay.
Okay. So the thing which is there in the actual physical note should keep on reducing. So that's why I will take shorter notes.
Okay.
Okay. Just looking at the short notes, everything else should flash in the mind.
All right.
Okay. Right. And also Feynman technique video you saw, right? So that's a similar idea only. There is not saying you teach the student looking at your notes. You just teach the student from your memory.
Okay.
Got it, no?
Got it.
Okay, fine. We'll meet tomorrow.
Okay.
Okay,
Thank
bye.
you.
Yeah, bye.
Bye.